Hello, welcome to my channel. We have been solving these past papers recently. So right now I have this mathematics, pure math 2 paper, and we are doing May-June 2024 exact paper. Okay, so we have already done question 1, 2, 3, 4, 5, I believe, right? You can watch in my previous videos. So we have done question up till 5, so let's do question number 6 right now. Okay, question number 6 is right here. Okay, so we are given a function. So this function is given as under the root sine 2x plus sine square 2x. Okay, so this is the function f of x, you can call it. Okay, now, and it is defined between 0 and pi by 6. Okay, so the first part is that find the shaded area using the trapezoidal rule, and you can make like two intervals. So this is pi by 6, so I can make pi by 12, right? So two intervals, pi by 12, pi by 12 each. So we need to find the area of the trapezoid. This starts from 0, so I will go from 0 to this point, and for this one I go from here to here. Okay, so these are the two trapezoids. We need to find this area. Okay, so this area is going to be, you see, for this for both trapezoid, the width is pi by 12, right? Okay, now for this one, the area is going to be the average of these two values. So with one value 0 and the second value. Okay, before I do this thing, yes, I forgot to something here before. So if I have x and f of x, right? So if x is 0, you can see that the f of x would be 0 as well, because they're all sine x and sine of 0 is 0. Okay, if x is pi by 12, okay, pi by 12 means 15 degree. Okay, so if this is pi by 12, then the value of the function is 3 under root by 2. Okay, you can check it over here. If it is 15 degree, so 2 times x is 30 degree, sine of 30 is 1 by 2. And similarly, this is sine of 2x is 1 by 2, 1 by 2 square is 1 by 4. So it is 1 by 2 plus 1 by 4 is 3 by 4. And we have the square root of 3 by 4, so this is 0 square 3 by 2, right? Okay, similarly, when we calculated the value of this function at pi by 6, okay, then it gave us the numerical value, one decimal value 1.27123. Okay, we will need these values for using the trapezoidal rule. Okay, so for the first trapezoid, the area is going to be 0 plus this value, which is square root 3 by 2 and divided by 2, right? So this times pi by 12 will give you the area of this trapezoid. Okay, plus, now for the next one, these two areas are square root 3 by 2 and plus 1.27123 divided by 2. So this will give you the area of the, this thing times pi by 12 will give you the area of this trapezoid. Okay, so we can simplify this thing as pi by 12, and this is square root by 3 by 2, so time 2, it will cancel. So I have just square root 3 by 2 and plus 1.27123 over 2. So this can be further simplified as pi by 24, and inside I have square root 3 plus 1.27123. Am I right? And this gives us the value 0.39313. Okay, so this is a numerical approximation for this integral. Okay, this is part A. The part B, shaded region is rotated completely about x-axis. Find the exact volume of the solid produced. Okay, so remember, this was my x-axis, and this was y-axis, and this is the third axis, and I have a function of x, right? This is x-axis, and here I have f of x on the y-axis, let's say. Okay, so if I rotate it around x-axis, it will become something like cylindrical shape, semi-cylindrical, you can say, right? So we need to find this volume. Okay, so if I look it from front, it will be, this is on the x-axis. So this was my function. And when I rotate it, it becomes like this, something like this, right? So this is 3D, you can see, imagine. So we need to find this volume. Okay, imagine we take a very thin disk in this whole volume. Okay, and what's going to be the volume of this disk? The width of this disk is only dx. Okay, so the volume of this disk is going to be, the area is pi r square, and r is the value of the function, and then I make the square root is gone, so it is sine 2x plus sine square 2x. Okay, and then I multiply with the width, which is dx. It will give me the volume of this small thin disk, and then I integrate it from 0 to pi by 6. It will give me the volume of this whole shape, right? So I need to evaluate this integral here. You can see this is pi under integral sine 2x dx from 0 to pi by 6, and plus again pi integral sine square 2x dx from 0 to pi by 6. Okay, so we need to evaluate these integrals. Okay, so let's do them one by one. So if I have integral of sine 2x dx from 0 to pi by 6, how will I do it? Okay, it's going to be negative cos 2x over 2. Okay, 0 to pi by 6. Because if I try to integrate, if I try to differentiate this thing, it's going to be minus 1 by 2. Cos 2x derivative is minus sine 2x into derivative of 2x is 2, so that 2 is gone, so this is going to be sine 2x, yes. So this is correct integration. Okay, and now I will take minus 1 by 2 outside. Inside I have cos 2x. So cos and 2 times this pi by 6 become pi by 3, right? Pi by 3 minus, when I put the 0, it's going to be cos of 0. Okay, now uh, cos of pi by 3, pi by 3 sine cosine is half, right? So this is minus 1 by 2, this is half, minus 0 to sine cosine is 1. Okay, so 1 by 2 minus 1 is minus 1 by 2, minus 1 by 2, so it will be plus 1 by 4, right? So this integration was very easy. Now the second one, sine square 2x. This is a bit challenging. 0 to pi by 6, right? Okay, now how will we evaluate this integration? Remember, uh, if I have cos 2x, it is cos square x minus sine square x. Remember? If I replace cosine by 1 minus sine, it will become 1 minus 2 sine square x. And if I replace sine by 1 minus cosine, it will become 2 cos square x minus 1. So these are the three formulas we have for cos 2x. Okay, I will use a middle one. So middle one is 2 sine square x is equal to 1 minus cos 2x, right? And I can divide it by 2 to get rid of this 2. Now, if I have sine square 2x, so if angle is doubled, it will become 1 minus cosine of 4x, right? Negligible now, over 2. So this is the thing I will use to solve my integration. Okay. So this is equal to, and I can split it up. So it is 1 by 2 integral dx and minus 1 by 2 integral cos 4x dx, and both of them are from 0 to pi by 6. 0 to pi by 6. Okay, so first integral will be 1, and there is going to be x 0 to pi by 6 minus 1 by 2. This is going to be sine 4x over 4, and limits are from 0 to pi by 6. You see, if I try to differentiate this part, so it's going to be 1 by 4. The derivative of sine 4x is cos 4x, and derivative 4x is 4. That cancel, and I have cosine of 4x. So this is correct. Okay. Okay, so this is 1 by 2. When I put upper limit, it is pi by 6 minus 0. Okay, minus, I can take it minus 1 over 8. Right? When I put upper limit, so sine 4 times pi by 6, it will become sine of 4 times pi by 6 means 2 pi by 3. All right? Minus sine of 0, 0. Okay, so this is pi by 12 minus 1 by 8. What is sine of 2 pi by 3? 2 pi by 3 means 120 degree. And 120 degrees sine is same as 60 degrees sine. So it is square root 3 by 2. Right? I hope it is clear. So it is pi by 12 minus square root 3 by 16. Right? Okay, now I will plug in these two integral values in my expression, this one, right? This is the expression I'm talking about, this one. So my volume of revolution is pi times this integral, which I found to be 1 by 4, okay, plus pi times this integral, which is equal to this whole thing. So pi by 12 minus square root 3 by 16. Okay, so let's simplify it a little bit, and that will be the exact value of volume. It is pi by 4 plus pi square by 12 and minus under root 3 pi by 16. Okay, so this is our final answer. Pi by 4 plus 12 pi by, yeah. Okay, I hope it's clear. Now, next question. The polynomial is given by this expression, and find the quotient when p of x is divided by this expression. Okay, so I will do it by long division. So I have 9x cubed plus 6x squared plus 12x plus k. And I want to divide it by 2x plus 3. Okay, so I will do it by 3x squared. 3x squared. Sorry, this is 3x. Yeah, I made a mistake. This is not 2, this is 3. 3x plus 2. Oh my goodness, I made, yeah. Okay, now when I multiply with 3, it will be 3, 3 are 9 and x cubed plus 6x squared, right? So now I will subtract, this plus will become minus, plus will become minus. This cancel, and I will have 12x plus k. And next thing I will do it with 4. So this is 12x and plus 8. So when I subtract this, It is going to be k minus 8. Okay, so basically what we saw over here, okay, that if I have this polynomial px divided by 3x plus 2, so this can be written as 3x squared plus 4 and plus k minus 8 divided by 3x plus 2. Is that clear? This long division gave us this expression. Okay, now this will be used in the next part. It is given that this integral px over 3x plus 2, okay, is equal to a plus log of 64. So we need to find the value of a and k. Okay, so first of all, this expression px over 3x plus 2, its integration from 1 to 6 dx. Is it same as this whole thing 3x squared plus 4 plus k minus 8 over 3x plus 2, and I will integrate this whole thing from 1 to 6 and dx, right? And when I integrate it, then I will have to equate it to a plus log of 64. So that we will do it later, okay? So first let's try to integrate this part. Okay, so this is going to be 3x squared integral dx from 1 to 6 plus 4 integral dx 1 to 6 plus, okay, this is, let me write it here. So plus k minus 8 is constant, I can take it outside, and integral, I have dx over 3x plus 2 from 1 to 6. Okay, if I do the derivative of 3x is 3, I put 3 over here and divide it by 3. It's the same thing, right? So I haven't changed anything. Okay, so now this integration is easy. You see, this is the integral derivative of x cube, right? Because when I differentiate x cube, it will become 3x squared. So x cube from 1 to 6 plus 4x 1 to 6. Am I right? Okay, what is here? Plus k minus 8 over 3. And this expression is the log of 3x plus 2. Am I right? And the limits of this expression is from 1 to 6. Okay, because when I integrate this thing, it will go to the log of 3x plus 2, right? Its denominators, log derivatives in the numerator. Okay, so this is 6 power 3 minus 1 power 3, okay, plus 4 times 6 minus 1, okay, and this is k minus 8 over 3, and inside I have, when I put the upper limit, 6 times 3 is 18 plus 2, 20. This is log of 20. Minus when I put lower limit, so 3 times 1 is 3 plus 2, 5. So log of 5. Okay. So this is 6 power 3 is 216 minus 1. So this is 215. Plus 6 minus 1 is 5. 5 times 4 is 20. Plus k minus 8 over 3. And this will become log of 20 over 5, right? So this is log of 20 over 5. Okay, so 215 plus 20 is 235. Okay, plus k minus 8 over 3, and this is log of 4. Okay, further simplify because I'm trying to bring it in this form, a plus log of 64, right? So I don't want something over here. So this is 235 plus, I can write it as log of 4 power k minus 8 over 3, right? Okay, now it is in this form a plus log of 64. So if I equate it to a plus log of 64, so I get something very interesting from here, that a a must be equal to 235. This is one thing I found here, right? Second thing I can see that the 64 should be equal to 4 times 4th power k minus 8 over 3, right? This 64, whatever this thing is, it should become 64. Okay, now 64 can be written as 4 power 3. So this is equal to 4 power k minus 8 over 3. So from here we conclude that 3 should be equal to k minus 8 over 3. So 3 things are 9. So k minus 8 is 9. So k is equal to 8 plus 9 is 17. Okay, so these are the two values, value of k and value of a. If I substitute these values in this polynomial expression, then I will have this integration solved. Okay, I hope you enjoyed this solution. If these videos are beneficial for you, then please do me a favor and subscribe my channel. Thank you for watching. See you in the next video.